Hi everyone and welcome to the series of learning Matlab. Now Matlab is a high-level programming language and interactive environment specifically designed for technical computing. We'll start the series by learning the fundamentals of Matlab. Then we will see how we can use Matlab to solve problems in linear algebra, calculus, probability and statistics. Now let's familiarize ourselves with the Matlab interface. Now here we have the command window, the script editor, then the workspace. Now command window, this is where um, you type code and interact with Matlab directly. It provides real-time results. For instance, if I prompt 4 plus 7, it immediately gives me the answer 11. The code prompted into the command window is not saved anywhere, so this can be used for doing simple and quick calculations. Now workspace, this is where all your variables, functions and data live. When a variable is declared and initialized in the script editor or the command window, it gets displayed here in the workspace. In the earlier example we saw the answer of the computation getting stored in a variable ans. Here you can see ans in the workspace bar. Now so think workspace as your working memory in Matlab. Then here we have the editor. This is your code playground. This is where you write scripts and functions to bring your ideas to life. This is used to do larger and more complex programs. Now let's start learning how to work with Matlab like any other programming language. Let's start by looking into variables, but before that let me clear the screen. So we use the clear function to clear the workspace. So clear function clears the workspace and CLC clears the command window. Now variables are where you store data types. A variable is a named value holder. Now programs use variables to temporarily store values in a computer's memory. See it like this: every data type or value in a program is stored in the computer memory, and variables are the names that we give to these memory spaces. Now for example, if I prompt a is equal to 3, a variable a having the integer value 3 gets stored in the program. Now Matlab handles different types of data: numbers, which include integers and floating point numbers. Now floating point numbers are nothing but decimal numbers. Then strings, logical or boolean values, arrays and matrices. Now some things to note while writing a variable name is that the name of the variable must always begin with either an uppercase English letter or a lowercase English letter. It may include letters, digits and underscore character. No other character is supported by Matlab for writing variable names. Then Matlab, one thing to note is that Matlab variable names are case sensitive, that is capital A and small a. So both are two different variables. Now when we prompt into Matlab a variable and an associated value, it gets displayed in the command window by default. For example, if I type b is equal to 4, see, it displays the variable and its value. If an assignment does not end with a semicolon, the result of the assignment is echoed to the command window. So if you do not want the command window to show the output, just append a semicolon at the end of the command. So here you can see the variable is set with the value 5 is created in the workspace, but the output is suppressed. So using a semicolon after writing a particular command avoids cluttering the screen with results. So we must get in the habit of placing semicolons at the end of the assignment lines to suppress display of assigned value by programs. Now sometimes you need to have variables without any particular value for calculations. For example, while plotting the curve of a polynomial function or finding the derivative of a function, so of an expression. So a very important function in Matlab called sims help us to do this. Now this function is part of the symbolic math toolbox and it's used to declare symbolic math variables. Now Toolboxes in MATLAB are collections of functions and files that extend the capabilities of MATLAB. They are similar to modules in Python and libraries in C. Now, Sims allows us to perform symbolic computations, which are computations involving symbols rather than specified numerical values. Now, you will understand this with an example. So, Sims x. Now this command creates a symbolic variable x. Now let's write a function y which is equal to some expression with x, say x square plus 2. So a variable y with the value x square plus 2 has been created in the workspace. Now to substitute x with some value, we use the subs function. Now let result be the variable wherein I store my answer. So when I type subs, then the first argument is the expression involving the symbolic variable which we are going to change. So in our case, it's x square plus 2. Result is equal to subs. So yeah, x square plus 2. We don't need to write the whole expression. We can just write y, since we had already declared y to be equal to x square plus 2. So y, then the symbolic variable x, then the last argument is the value which we are substituting for x, which is 5. So this will return us with the answer 27. Now 27, it's 5 square, which is 25 plus 2. So this is how you use a Sims function, and note that this is part of the symbolic MATLAB toolbox. So this will not work if you don't have symbolic MATLAB toolbox added on into your MATLAB environment. Now in MATLAB there are several predefined variables that have special meaning. For example, pi represents the mathematical constant pi. Then we have I and j, which represent imaginary unit. Then we have I and f, which represents positive infinity. So operations like this returns us with the answer I and f. Then we have NaN, which stands for not a number, and this is the result of undefined mathematical operations in MATLAB. So for example, if I prompt something like 0 divided by 0, MATLAB returns me with the answer NaN. So then another predefined symbol in MATLAB is ANS. We had already seen ANS. ANS is used to store values of computation. Now let's look at, so that's all about variables. Now let's look at commenting in MATLAB. Now comments are lines which are not read by the system. The system just ignores these, and MATLAB offers two ways to add comments. We have line comment. So this is a line comment. Then we have block comments. Now line comments are everything after the percent sign. This is how you write a line comment. So we start a line with a percent sign. So everything after the percent sign on that line will be treated as a comment and ignored by MATLAB, and this is useful for adding brief explanations at the end of lines of code. Next, we have block comments. Now block, we use a percentage symbol and curly bracket to enclose a multi-line comment. So this is helpful for documenting longer sections of code or explaining a complex part of your code. For example, now this is a now this is a multi-line comment, and so while starting the block of comment and ending the block of comment, we first type the percent sign and then the curly bracket. Now we had already seen that MATLAB can perform all arithmetic operations such as addition, subtraction. For multiplication we use the star symbol. For division we had already seen we use the slash symbol for doing division. Now for trigonometric functions we can use sine, cos and tan functions with the radian values of angle enclosed in parentheses. For example, sine say some 22 radian. So note that this value is in radian. So to in MATLAB uses radians as the default unit for angles. Now remember, to convert degrees to radians we have a function called rad to degree, rad to dig. So rad is say pi by 4. Now this will convert degrees radians to degrees, and or we can convert degrees to radian using deg to rad function. So yeah, this is approximately equal to pi by 4. So and to find sine, so if I write sine of 0.785, so yeah, this will return me the answer. So please note that cosec of some number, say the same 0.78, now this will not give us any answer. MATLAB will show an error since MATLAB does not have a function named cosec. So instead of cosec we use CSC to find cosecant of a radian angle. So now this will return us with the cosecant of radian value. Now if you look at this calculation, we all know that cos pi by 2 is 0, but here MATLAB is showing the value of cos pi by 2 to be some fancy number. Now this is because pi is a floating point approximation of the true value of the irrational number pi. So the answer will be slightly inaccurate. So to solve the problem we have the cos pi function. Now cos pi of 1 by 2, this will return us, so this returns the value of cos pi by 2. So whatever argument you pass inside the bracket, MATLAB multiplies the input number with pi and then returns the result. So this will give us 0. So we have similarly we have the sine pi function, but we don't have tan pi, cot pi. There are no tan pi, cot pi functions. We just have the sine pi function and cos pi function. So cos pi 1 by 2 returns cos pi by 2, which is 0. So remember, functions like cos pi and sine pi return the trigonometric ratio of pi, a trigonometric ratio of pi into the argument passed into the function. Now to find the inverse of these trigonometric values, we just need to prepend an a to the beginning of these trigonometric functions. For example, a sine 0, yeah, this will return as 0. So this will give you the inverse of sine of 0. Now this will not work for cos pi and sine pi function. Now a sine pi and a cos pi, they don't exist in MATLAB. So but it works for a sine, a cos, a tan, a cot, etc. Now to calculate trigonometric values of degree values directly, just append a d at the end of each function name. For example, sine d of 30 gives us the sine of 30 degrees, which is 0.5. So Similarly, there are cos d, tan d, cot d functions in MATLAB. Now, some other functions in MATLAB include exp of exp. Now, exp of some number returns the exponential e raised to uh, x of that number. Now, log of x. Now, log of some number. Now, this function returns the natural logarithm of that number x. For complex or negative numbers, the complex logarithm is returned. Then we have the log 10 function. The log 10 function returns the common logarithm of a number of the common logarithm or the base 10 logarithm of a number. Another example, say 100. So yeah, this function returns the common logarithm or the base 10 logarithm of the number passed into the function. Now we have the log 2 function, which returns the which computes the base 2 logarithm of x. Then we have the hat operation. Hat operation is used for power for computing the power of of a number. For example, if I write 8 hat 2, this will return me with 8 raised to the power 2, which is 64. Now then we have the ceil function. Ceil function rounds the elements of the number to the nearest integer greater than or equal to that to the number which we had input. For example, if I write 4.7, this will return 5. Now ceil of 4.3 will also return 5. Then we have the floor function, which rounds the elements inside, which rounds the input to the nearest integer less than or equal to the input. For example, 4.3, this will return us with 4. Again, floor of 4.7 will also return us 4. Next we have the round function. Now round function is used to round a number to the nearest integer. Next, fix function. Now the fix function, it returns the whole number part of the input. So in this case it returns -9, and in this case it will return 4. So the fixed function, it returns the whole number part of the decimal number. Now we have the rem function. Now rem function finds the remainder of a number when divided by the another number. So rem ab function finds the remainder after division of a by b. So where a is the dividend and b is the divisor. Next we have the abs function or the absolute function, which returns us with the magnitude of a number. So abs function returns the magnitude. This is useful while finding the magnitude of vectors and complex numbers. Then we have another important function is the factor function, which returns the prime factors of a number. Here in this case 125, the prime factors are 5, 5 and 5. Now so in this video we saw what variables are in MATLAB and some basic functions. In the next video we will see how we can display output on the screen and how we can read input from the user. So thanks for watching. Bye.